Hello students, today's topic is diazotization and its mechanism. Diazotization is a chemical reaction which is used to convert a primary aromatic amine to its corresponding diazonium salt using nitrous acid at a low temperature like 0 to 5 degrees Celsius. See, the general reaction is given here. The primary aryl amine is converted into aryl diazonium salt using the reagents in this particular reaction condition. Now let me tell you a little bit about primary aryl amine. We all know that NH3 is ammonia. When you replace one of its hydrogens with an aryl group or an aromatic ring, you will be getting a primary aryl amine, which is of this form. See students, Amylin is an example for a simple primary aryl amine. Here, one of the hydrogens of ammonia is replaced by benzene ring. So that is about primary aryl amine. Now coming to aryl diazonium salt. Here, azo refers to nitrogens and di means 2. So, aryl diazonium salts are a group of organic compounds which have a general formula like this. So, aryl group is attached to 2 nitrogens which are bonded in this manner. N triple bond N with positive charge over this nitrogen. An anion X minus from the mineral acid can help in stabilizing positive charge over this nitrogen. So, if you are using HCl, hydrochloric acid, as the mineral acid, then chloride ion can stabilize the positive charge over nitrogen. You can also represent the aryl diazonium salt in this fashion. Aryl group N2 plus X minus. These aryl diazonium salts are found to be extremely unstable at high temperatures. That's why while carrying out the diazotization reaction, we have to maintain low temperatures like 0 to 5 degrees centigrade by using ice bath. Now coming to the main reagent, that is HNO2 or nitrous acid. This nitrous acid is not like nitric acid. As we all know, nitric acid is quite a stable acid. That's why it can be stored in bottles in the chemical laboratory. But nitrous acid is found to be an unstable acid. Therefore, whenever we have reactions that are involving nitrous acid, this particular compound is produced within the test tube or within the reaction flask during the course of reaction itself. So let's see how to produce nitrous acid during a reaction. We have to take a salt NaNO2, that is sodium nitrite. Remember students, it is not nitrate, it is nitrite NO2, and treat it with concentrated hydrochloric acid. At that time, a simple reaction takes place. We get NaCl and HNO2 as the products. So what is HNO2? It is nothing but nitrous acid. Let me write the structure of HNO2 here. N double bond O, single bond O, H, HNO2. This is the structure of nitrous acid. So the main reagent is ready now. So here we have the overall chemical reaction for diazotization of aniline. Take aniline, treat it with sodium nitrite and 2 moles of HCl. So here what is produced? Nitrous acid is produced. Then the reaction takes place. Aniline gets converted into benzene diazonium chloride. Plus sodium chloride is produced and 2 moles of water is also produced. Now I will explain you the mechanism of this reaction. As we already discussed, the very first step in diazotization is production of nitrous acid. And how to produce it? So take NaNO2, treat it with hydrochloric acid, we get NaCl and HNO2, that is nitrous acid. What is its structure? N double bond O, single bond OH. So this is the first step. Now let's see what is the second step. In the second step, nitrous acid reacts with H plus ion of hydrochloric acid. The lone pair of electron on oxygen attacks H plus ion of HCl, thereby the hydrogen chlorine bond breaks in this fashion. So we get something like this. The lone pair of electron on oxygen is donated to H plus ion. That's why a positive charge is developed over oxygen. This system is not stable as there is positive charge over electronegative oxygen. So how can we stabilize it? It is simple. The nitrogen-oxygen bond breaks in this manner so that a molecule of water is lost. So what do we get now? N plus double bond O. This ion is called as nitrosonium ion. Now, the positive charge on this ion can move between nitrogen and oxygen. So how can it happen? The lone pair of electron on oxygen can shift here, producing N triple bond O, positive charge on oxygen. So this is another resonance structure of nitrosonium ion. These are the two possible resonance structures of nitrosonium ion. Now the attacking agent is ready. Let's see how the reaction proceeds. In the third step, Amylin reacts with this nitrosonium ion, N triple bond O plus. So what happens here is, lone pair of electron on nitrogen of aniline attacks this nitrogen atom. Thereby, the pi bond shifts in this fashion, neutralizing positive charge over the oxygen. So we get something like this. As this nitrogen donated lone pair of electrons to nitrosonium ion, positive charge is developed over this nitrogen. The product formed here is again not stable because we have 4 bonds to nitrogen and it carries a positive charge also. So how to stabilize this thing? We will take the help of this water molecule that is lost in this step. The lone pair of electrons on this oxygen can abstract the proton from this compound, thereby breaking the bond in this fashion. So what happens is, the bonding electrons will be shifted to N+. So positive charge on nitrogen is neutralized now. So what is the product here? This is the product formed. And what happens to water molecule when it combines with H plus ion? Simple, it gets converted into a hydronium ion minus H3O plus. Now we will see what happens in the next step. The formed compound, it reacts with this hydronium ion. I'll represent the hydronium ion like this. OH2 plus, which is attached to a hydrogen. So this is nothing but H3O plus or hydronium ion. Now what happens is, the lone pair of electron on this oxygen can take up proton from hydronium ion, thereby producing a water molecule like this. A product of this type is obtained, but positive charge on oxygen is not good, so the molecule somehow tries to stabilize it. How? The lone pair of electron on this nitrogen shifts here, so the pi bond shifts in this fashion to neutralize the positive charge. So we get a structure like this. Now these two compounds are in equilibrium with each other. But both the things are not so stable, so the reaction must continue. Again, the water lost from this reaction will come here. What it does is, the lone pair of electron on this oxygen will abstract the proton from this compound. Hence, the nitrogen-hydrogen bond, it breaks in this fashion. So what happens? The positive charge on nitrogen is neutralized. And what happens to water? When it combines with H plus ion, hydronium ion is produced and it is lost from the system. And the product here is, this is the product. Again, the reaction is not over yet. In the next step, the OH group of this compound will react with the lost hydronium ion. I'll represent hydronium ion in this way. The lone pair of electron on oxygen abstracts a proton from hydronium ion, thereby a water molecule is lost, minus H2O. So what is the product obtained? This is the product obtained. Now, need not to explain, the system is unstable because there is positive charge over oxygen and it can be stabilized only with the loss of a water molecule. But how can that happen? Simple. Lone pair of electron on nitrogen shifts here and the nitrogen-oxygen bond breaks in this way, thereby losing a molecule of water. You get something like this. So benzene ring with azo group is produced now. This compound takes the help of chloride ion, which is lost in the second step in this fashion, so that positive charge on nitrogen is stabilized. Now what is the name of this compound? Benzene diazonium chloride, or the final product of diazotization reaction. You can also represent this compound in this manner. Benzene ring that is attached to N2 plus, which is stabilized by the anion Cl minus. This is benzene diazonium chloride. These diazonium salts are very versatile compounds. Using these organic compounds as starting materials, you can produce a number of other organic compounds. For example, chlorobenzene, bromobenzene, etc. Let me summarize the mechanism once again. 3 major steps are involved here. In the first step, nitrous acid is produced using sodium nitrite and hydrochloric acid. In the second step, the nitrous acid reacts with proton of hydrochloric acid, producing the main attacking agent, that is the nitrosonium ion. In the third step, Amylin reacts with nitrosonium ion in the following manner. Producing the final product. The third step might look little complex for you, but it is actually simple. So if I should summarize the third step, you can remember in this fashion. In the first step, attack of nitrosonium ion, then attack of water followed by hydronium ion. In the next step, 2 equilibrium structures. Again comes water, then hydronium ion. In the final step, loss of water and the final product is obtained. You can remember it in this fashion. Water, hydronium ion, water, hydronium ion, like that. If needed, you may take down the screenshot of entire mechanism and the introduction part. So students, that was about diazotization reaction and its mechanism. Thank you so much for watching.